Table of contents: 1. Overview of lab. 2. Calculation of magnetic dipole moment. 3. Conceptual model. And 4. Discussion. Overview of lab. The first step of lab was compensating for the magnetic north. In order to compensate for the magnetic north, I placed my phone/magnetometer on the floor and rotated it until the x component was close to 0 as possible. Once the x component was close to 0, the phone would be aligned with Earth's north-south axis, and the measure tape was aligned with the bottom of the phone so that the tape was now aligned with Earth's east and west axis. To check that this magnetometer was aligned correctly, I looked up the coordinates of my general location and its net magnetic field to see if the net magnetic field on my phone was similar. The general location I chose was Hinesville, Georgia, and its net magnetic field was about 47.3 microteslas. Next was finding where the magnetometer sensor was on the phone. In order to do this, I positioned the phone along the perpendicular tape and moved it until the absolute value of the y component was at a minimum and the x component was at a maximum. Next, I placed the tape where the bar magnet and the location where on the tape aligned and placed that tape on the phone. Then I rotated the phone about 90 degrees and did the same thing, in which I found the location where the y was at a minimum and the x component was at a maximum, and then placed the tape on over the phone where it aligned with the bar magnet and the measured tape. At this cross section or intersection was where the magnetometer sensor was on the phone. This is shown in the top image on the slide. Next, I completed the data analysis. Using the measurement tape, I recorded the distances needed to get a specific magnetic field, for example, 70 microteslas, and calculated the averages of the distance in order to calculate the distance dependence and the magnetic dipole moment, which will be discussed in the next slide. The overall of this part of the experiment is shown in the image with the graph on it. Next, I had to find the off-axis magnetic field. In order to do this, I aligned the cell phone with the measurement tape so that the net magnetic field on the magnetometer was approximately 100 microteslas, and recorded that distance, and then from there placed the tape over that location and moved the phone upwards the distance, the same distance. The magnetic field components at this location were recorded and used to calculate the net magnetic field of the off-axis location, which is shown in the graph below at the bottom section of this image table. And the image of how this section of the lab was completed is to the left. Calculation of magnetic dipole moment. Using this equation shown on the screen and the R values found during the experiment, we calculated the K and N values. And by graphing the natural log of the magnetic field X component versus the natural log of the R, which was the distance away from the magnet that resulted in the specific magnetic field X component, we got a straight line of Y equals negative 3.5194x minus 9.5542, in which n was the slope and the intercept is the natural log of k. Both n and k are constants, and n is the distance dependence, which is negative. Also, because the natural log of k was negative 9.5542, k would be 0.00007. By simplifying this last equation of the absolute value of the net magnetic field, it was calculated that the magnetic dipole moment was approximately 350 ampere square meters. Computational model. This model was based off of this equation shown below. Discussion. This experiment showed that as the magnetometer moved closer to the magnet, the measured X component of the magnetic field increased. It also showed that the compensation for the magnetic north was very important. If we hadn't done that, our results would have been very skewed, and there wouldn't have been a neutral component to see if we had rotated the phone correctly. If we had two magnets instead of one, the magnetic field would have been greater than what we had in this experiment. Both the computed and the measured values of the net magnetic field were very similar.